1 plus
1 plus 2 ln theta.
1 plus 2
ln theta.
ln theta. Okay. And we basically the required is find y prime. So the differentiation is required, y prime is required. Okay. So as I told you, you can observe by yourself. Means if you feel argument is very easy, so no need to use any property, you can go to differentiate directly. But if you think no, means the argument is quite complicated. So first simplify the argument, please. Right. So how we perform the properties, please. So first of all, you can see this is basically quotient. And yes, we know very well. If the argument has fraction, you can write as a subtraction. Okay. So fraction change into subtraction. So this is ln. I have sine theta times cosine theta with square root. Then minus. Means it is called ln numerator minus ln denominator. 1 plus 2 ln theta. So here,
If you make this the power of half, won't it be easier?
yeah, of course we will do, because we have to use next property like that.
You can use power.
Yes. So now, next you can see here that this argument has power. Square root means how much power? Actually, it has power half, 1 by 2. And as per the first property of law, if the argument has power, so the power can bring down. Remember the first property?
Yes.
Yes. So you can write this is here. So you have ln multiplied by sine theta. Okay. Please tell me, can you use any property here? Yes, we cannot use any property here because
There's no problem.
there is addition between them, and as per the law properties, there is no rule if the argument have addition. No. So keep this one as it is.
That had power.
So is can come down?
It will come.
Yes, yes. So this one, please copy as it is. So this is ln with the argument 1 plus 2 times ln theta.
Can you simplify it more?
Yes, we can. Look at this. This argument has product.
Yes.
And if the argument has product, how you like?
Addition.
As addition, you write ln sine theta plus ln cosine theta. But be careful, please. 1 by 2 is already outside. This 1 by 2 is with both of them in place. So how do you apply here the property to get it? 1 by 2 is as it is, please. So you have now ln sine theta and plus ln cosine theta. We'll just use this, product property, base product change into addition, please. And this one as it is minus ln with the argument 1 plus 2 ln theta.
No.
It's up to you, sir. You can again distribute one half with this, time half with this, so that we can get more simplified form of the question. I have 1 by 2 ln sine theta plus again 1 by 2 ln cosine theta, then minus ln with the argument 1 plus 2 ln theta. Understand? I think now it's a simplified form of the question. Please, we did not start the derivative. All the steps we do for the sake of simplification. Now, this is your y, we see, it's a question, please. Now we differentiate. Now we say y prime. Y prime, please. Okay. 1 by 2 is multiplying. So as per the rule of derivative, if you have a constant as a product, 1 by 2 will not change because it is constant which is multiplying with the function. So no change in derivative of 1 by 2. Take the ln sine theta derivative. So here you can see the argument of ln how much? Sine. So by the rule, 1 over argument times argument derivative, sine theta derivative, cosine theta. Okay. Plus again same thing. 1 by 2 no change, please. 1 over argument, which is cosine theta,
Times negative.
times negative sine theta, because cosine derivative is negative sine. Yes or no?
Yes.
Okay. Minus, now here, please, this is the argument. 1 plus 2 times ln theta. So 1 over argument, which is 1 plus 2 ln theta, times the derivative of 1 plus 2 ln theta. So 1 is constant. How much derivative?
Two.
It is 0. Huh? Means 1. 1, it is 0. Right. No need to write 1, no problem. And next, it is 2 times. And ln theta derivative is 1 over theta.
So it's 2 over theta.
So it is basically 2 over theta. Yes. Good. So let's take one more step to simplify this answer. So cosine by sine is cotan. So you have cotan theta over 2. Okay. Here, this is positive, this is negative, it is negative. Sine by cosine is tan. So you have tan theta and divide by 2. Okay. Here, please, this is product. Huh? 2 times 1 by 3. So this is 2 by 3 because 0 plus 2 times 3 is the same thing. Am I right, this? So how you write this one, please? So this is now negative sign. In numerator, you have 2 divided by, this is theta, and it is multiplying with 1 plus 2 ln theta. So this is your y prime in simplified form. So please let me know, do you understand, please, this differentiation?
First step, while we put who sign
Here,
no. First,
here, please.
yeah. Why did you put 1/2?
Because I have square root, and square means half power.
Oh, I thought it was all over that.
No, it's only with the numerator.
It's only on the numerator.
Numerator.
Thank you.
It's clear? Good. So this is the way to use the properties of log first, and then you have to go for differentiation. Clear? Should we go next question, please? Okay, please, you can copy this right now.
Doctor, can you repeat just the last simplification?
This one?
Yes.
Actually, cosine by sine is cosine.
Cotton, yes.
So, and divide by 2 is as it is.
Yes.
Then sine by cosine is tangent.
Yes, over 2.
And this 2 is as it is.
Yes, then minus.
Then minus this 2 is as it is.
And the theta is.
Theta is multiplying. Yeah, because it is basically 2, it is basically, this is 2 by theta like that. So 2 is here.
But
and
you
this.
can't expand the theta inside.
No need. No need. I mean, because it's a simplified form. If you expand, it becomes, expansion, not the, simplification. So keep it as. Right? Yes, please, you are done? Okay, good. Now, let's take one more question, please, from this same concept. Sorry.
$29.
29? This one?
Yes.
Okay. So let's start this 29 question, please. ln 1 over x times x plus 1 square root. 29. So y is equal to ln 1 over x times square root of x plus 1. Right, it's almost same thing, means that it has again the argument as fraction please. So for the sake of simplification, you can write ln numerator minus ln denominator. The first property, sorry, means the property of quotient. If argument has quotient division,
Minus.
so you can use fraction minus. So means numerator minus denominator. Okay. Now we already know ln1 how much? 0. ln1 is 0. Minus. Okay, look at here. This argument has product. So be careful. We have to use bracket here. Now apply. It is ln x and plus y plus, because x and x plus 1 are multiplying. The argument has product. So that's why plus. ln x plus 1. Square root means how much power? Half. So we can write x plus 1 square root like half power. And we take it down to half because it has the, it is an argument power. Yes, you're right. So this here is gone, no need. So this is minus sign, okay? Okay, we keep bracket, not right now. So it is ln x. Then because argument has power, we can write power down. Half ln with the argument x plus 1. Understand, please? And now you can multiply the negative sign with all. Multiply all of that with negative sign. So your simplified form of the function y is basically minus ln x minus 1 by 2 ln with the argument x plus 1. Now you can differentiate these. Now calculate y prime. So minus sign as it is, ln x derivative is how much? 1 over x. You know, for the argument times argument derivative is 1. Okay. Again, half is as it is. 1 over x plus 1 and times the derivative of x plus 1, which is 1. So no need to write here 1 please. Right, now we have simplified more please, because here we can use as a simplification, what we can use here for simplification case. We can use which method, what we call common denominator. common denominator. So basically we multiply up and down by 2 times x plus 1. So look at here. This one will multiply that and this by that so that they can get same, okay? So this quantity x will be multiplied by 2 times x plus 1. So if you are multiplying down, same you have to multiply up. Yes, to make balance. Now look at here. This one should be multiplied by what?
Yes.
Very good. X. Also up. Now check. Are the same as a denominator? So are the same, please? Yes. So it is called common denominator. So I can write 2 times x into x plus 1. Now please, the numerator, look at here. This is minus sign. Minus sign. So negative 2x and negative 2, and then I have negative x. So finally, this negative 2x and minus x, how much? Negative 3x. Very good. So finally, please, y prime is equal negative 3x, negative 2, and divide by 2 times x and x plus 1. And that's all. This is all simplified.
We need to simplify it like this.
Yeah, please, we simplify, have marks for simplification. So I hope you understand the question. Very good. Let's take a few more questions, please. Actually, we have started the integration as well. Let me finish the derivative portion completely, then we start integration. Okay, so why not we, okay, please. 70, please try yourself now. Go on. Write the question number 70, please. And please try.
You apply and
Exactly. You know how we ask this question, please?
yeah, you put it in the both.
Actually, look at the question. This is cubic root, means the whole stuff has power 1 by 3. Then it is the product, then also product, then you have quotient. So if you go without any, you can say simplification, if you go directly for differentiation, I don't think so we can manage. It's very complicated.
And here we don't have them.
Yeah, so what we do?
Yep.
We apply and then both sides, please. Means what I mean, how you start the question, please.
And then why?
Basically, you start them like that. Apply and then both sides, please. Now it becomes argument. And you know very well, if the argument has the power or product or quotient, so we can use properties. Yes, please.
Put 1/3 outside and then you solve as the.
Actually, yes, not don't please. 1 by 3 is the power, so argument has power, so 1 by 3 come before the ln. Then this argument has further properties. It has product, so addition, it has subtraction, sorry, it has quotient, so subtraction. So you can apply all the properties, please. Come on, let's try. Please, let's try. So how you basically differentiate 70 question, please? First of all, apply ln both sides, please. So that we can simplify first this stuff. Then we take the derivatives. Actually, you can apply properties together as well. In one step, you can apply some properties. If you want, you can go step by step. Or if you think I can apply, product property or subtraction in one step, okay, you can go, no problem. You can skip the steps. Of course, no problem. But be careful, means you are on the right track. And the question, please, is the question. So this is y is equal to x times
X plus one.
x plus one, x minus two. And x plus one,
X minus two.
and
Over.
divide by
X squared plus one
x squared plus one,
times two x plus three.
x plus three, and they have cubic root. Right, and we need y prime, find y. Right. So as I told you, means if you go directly, differentiation becomes mess. Cannot control this. So it's better, first of all, simplify this stuff. But we have no function for simplifications. What we can do, we apply both sides. Element. Element. Yes, please.
We can cross the x square plus one.
Means how we cross?
Like x side the bracket. Then cross.
Like that, or
Yeah, x square plus six.
means you means but product?
Yes.
It's okay. You can multiply first. It's okay. X squared plus x. Then actually the best option is that first multiply these two, and then times x. But again means you have here quotient, and then you have chain rule. Yes, please.
Is this implicit? So that point, you have to do this.
No, it's not implicit. No,
Okay.
because implicit means the other side you have combination of x and y. But here is only one side is x, means you have explicitly y value here. Okay.
Doctor, it's not really understand why did we put ln on both sides?
Because we have to simplify first this one. We need simplification. Before in the questions, it was already available
Yeah.
ln. That's why. But this time there is no available ln. Means look at here. It was ln already. We use the properties. Now there's no ln.
So every time we need.
So how I make this this question simplified without ln? So I need ln. So what I did, I applied both sides ln piece.
For both questions or
Yeah, of course, means both sides.
After simplification, I just use the E and then bring it back.
No, need. That's not it. What is the objective? What we need? Y prime. We need y prime.
How do you get rid of that and why?
Yes, we can. Just wait. Yes, please.
And the question is, like, say that we need to apply ln, or we just have.
No. The question says find y prime. There's no guidelines for you. As I told you, it's your choice. If you think I can differentiate this one without any simplification, most welcome. Go ahead. But if you think no, it's very complicated. So for simplification, please apply ln both sides first. So it's your choice, please. So can you answer without simplification?
no, I think it's better.
Yeah, I'm asking. What is it?
Yeah, very complicated.
It's very complicated. It takes time and somewhere high chances of the mistake. Okay? So it's better to simplify first, and because no ln in the question, so you apply by use step, please. So I apply both side ln. Now I first simplify this stuff. This side I simplify first. Then I will apply derivative. Okay? So this one, because is a cubic root, please. It's not multiplication, it is here. 3 is here. The index. So basically you can write this one. How I can write this one?
Power.
Power 1 by 3. Yes, the cubic root.
Then
Now, as we apply ln both sides, it becomes now argument, correct? And by the property of log function, if argument has power, we can take it down. So please don't mind, I just take this power here because we know very well this is basically argument property. Yes or no? Good. Now 1 by 3 is multiplying with all the stuff which is inside, please. So keep 1 by 3 with you. And just simplify inside stuff, please. So please, we are not taking right now derivative. We are now simplifying first, please. So look at here. Is 1 by 3 is please as it is I copy here. Now look at here. This is the argument, and we have quotient, right? Yes.
But
If you want, you can apply same time two properties. Forget it. I have quotient, also I have product. So if you don't mind, look at it. To save time in exam, please, you can apply two or three properties together. Means I keep the power down, then I can try to get here. ln x plus ln x plus 1 plus ln x minus 2. Yes or no? Because 1, 2, 3, they are multiplying. So if the argument has product, you can write as addition, right? After this product, with this three product, I make addition. You have this division. And division means what? Minus. Division means minus. Fraction means minus. So I put minus. And look at here, in denominator, again you have product.
So plus.
So
ln.
because I have negative sign, so I use the bracket here. And look at here. And then xk plus 1, then what? Plus. Why plus? Because these two are product.
Yeah.
Multiplication. Then I have ln the argument 2x plus 3. Get the notice here. So this bracket here and the one more bracket which is here. So please, again, I'm sorry, I apply two properties together. Otherwise, you can do first, you can apply this quotient with a subtraction. Then the next step, you add of the product. Do you understand it here? Means I use two properties together, okay?
You put ln for each one, and then you did the product as
Addition.
addition.
Yes.
The division
Division as a sum, yes, exactly. Then again addition because they also are have product.
all at once.
All in once, yes. Right, so do one thing, this negative sign you can open so that inside we have only one, value here. So this is now 1/3, and then we have ln x plus ln x plus 1. Then we have plus ln with the argument x minus 2. Then we minus ln with the argument x squared plus 1. And then because it is minus, the plus sign change to minus sign. And ln 2x plus 3. I hope you understand it. I just open this bracket. I just rewrite this one. Is okay?
Yes.
Good. This side, what you have? ln y, not y, ln y, because you applied ln in the first step, both sides. Is clear now? Now, because we need y prime, so we apply both side differentiation. Both sides, because we did derivative y prime. So differentiate your left side, differentiate your right side. Now, please tell me, what is the derivative of ln y?
1/y, then
1 over argument multiply the derivative of the argument.
Oh, wait, right.
isn't that called implicit or implicit? I thought that's called implicit. I thought that's called implicit.
It's not implicit equation, no. The equation is explicit, but because y differentiation is y prime, so we know very well because the derivative of y with respect to x is not 1. So you understand? Please, again, look at here. What is the argument here? Y. So 1 over y
Times the derivative.
times the derivative of y. So what is the derivative of y? Dy over dx. You can write dy over dx, or in short, y prime. Do you understand what I mean? Or it is y prime. Now you can tell me how you get y prime, please. Okay, now here 1/3 is constant, no change, please, because 1/3 is multiplying with the functions. So 1/3, no change, keep as it is. Now differentiate 1/1 everything. So 1 by x, 1 over x plus 1, right? Plus 1 over x minus 2, then minus 1 over x squared plus 1
Times 2.
times 2x. and 1 over 2x plus 3 times 2, and please close the bracket because 1 by 3 is multiplying.
Doctor, you not that into one and you use it from there.
Exactly, means 1 over argument times argument derivative. 1 over argument times argument derivative, like that, please.
Yeah, it's supposed to be like, for example, the 1 over x 1 multiplied by 1, right? But
Yeah, because 1 no need, yes, yes.
here we wrote 2x because
Because the x squared plus 1 derivative is 2x.
yeah, the plus 1 is 0 and the x.
Yes, yes, exactly, exactly. Okay, now we need some simplification, please. Sorry, not simplification. First, we need y prime. We need y prime here. This is y prime. And it's divided by y. We don't need y, please. Do you know what it means by y? Y is representing what? The question. Y is basically, y means the question. This is why. Why this one? So, first of all, please, because we need only y prime. So, to get only y prime, we have to multiply y both sides. Yes, please multiply y both sides because we need only y prime. We don't need y.
Because y over y is 1.
So this and is cancel out. Now we have y prime, which is our requirement. So what is y prime now, please? So y prime is equal.
Half y.
Yeah, no, 1 by 3. Yeah. Actually, now I will not suggest you to make the common denominator because it takes too much time now. So if the if fractions are too much, so means no need to make the common denominator. If it is only 2 or 3, so you can make, okay? Because you should make here common denominator, so you need 7 to 8 more minutes in exam to make the common denominator. So please keep at this. I'll just you simplify now, please. So this is we have y here, please. Y means question. So please just copy paste here y value. Y value is basically question. Just copy the question here. 1 times. Look at here. This is 1. Look at here. 1 by 3. Then just copy paste same thing. 1 by x plus 1 by x plus 1 plus 1 by x minus 2 minus 2x divided by x squared plus 1 minus 2 divided by 2x plus 3 and multiply by y. Y means the question. What's the question? Cubic root of
X plus.
Yeah.
this is cubic root of x plus 1. Sorry, x times x plus 1 times x minus 2 divided by
X.
x squared plus 1 and times 2x plus 3, and that's all. That's all. We get the answer.
What's the final?
The final answer. So in these questions where you are applying ln from your side, you always get in the answer times y. Y means a question.
Only multiply with the, you will vote,
Because what is that?
why?
Y. And y is representing what? What is y? What is y? This is y. That's why.
Because we went one from the beginning.
No, it's not the beginning. Basically, the answer times y. And we are getting y prime. So basically, we don't allow in y prime y. So please put the y value. Y is in x. Y is a question. Look at here. So I just put the question.
Y represents the question.
The question, yes, exactly. So this is the answer of the derivative y prime.
The answer of the question.
The answer is the
Question and the answer.
yeah. Actually, if you look at the derivative rule of natural law, it says 1 over argument means you have to copy paste same argument, and this is the argument, please. 1 over argument times argument derivative. So this is the argument and times is the derivative. Hope you understand it. That's why it's coming like that. Okay? So when we say ln x derivative, what we say? We copy paste argument as it is, 1 over the argument, multiply argument derivative. So this is why prime. So you can see here, please, the questions from 57 until 70 is your choice. If you think I can differentiate 65% without any ln, go ahead, no problem. If you think no, I first simplify, then I differentiate, is your choice. So similarly, for example, is 69th question or 67th question, please. For example, if you think, no, I don't need any ln property here. So I go with the quotient rule. Okay, go, please.
Doctor, why do you read out the question? Like, why do we read out?
No, I already had the question, please. The thing is that, look at here, in my answer, I have this multiply y. I just put the y value. What is y value? Y is my question. This is my y value, please. I just put the y value, please. Hope you understand. Yes, please.
Doctor, what do you advise us? Like, use the ln or quotient?
As I told you, is your understanding. If you feel,
I know, but
for example, okay, I ask you, look at here, 67 question. Can you differentiate directly?
yes, you can use the quotient rule.
Then correct. Then chain.
Yeah. Put the 2 over 3, then the derivatives of the
So it makes this complicated.
yes.
So use LN. Become much easier for you.
But 63 you can do it without.
63, yeah, it's up to you. If you apply ln, they become addition, and 1 second you get the answer. Otherwise, you had to first multiply all and then take the derivative. It's your choice. No problem. It's your choice. Just is your understanding level. If you think, yeah, I'm very good, I can go with this question 6-7 without any ln, go ahead. Please.
And why didn't you run over it? You did that when you saw.
We didn't expect.
Be the same, that's why.
Oh, means I multiply with each one. At the end is a common factor.
Yeah, but it's fine if we.
I think it's better because I have 1 by 3, 1 by 3, 1 by 3, 1. So it's better to take outside as a common factor. It's much simplified form. That's why. Okay?
Okay. Like when you give us one of these, how can we know like this is we can use the natural logarithms? Like, in the question there is no,
For simplification purpose, there is no other option.
there's no other.
For example, as you asked the question that, for example, here, can I means I use ln or not or means what I use here. So for example, if you want to simplify this part, there's only one option. If you have here natural log, means if it is argument, then you can make simplification. There is no other function in mathematics who can help you to simplify. Not at all.
Only the
Only
the natural-
ln, yes, means only logs. That's it. By the way, please, I repeated in the last class as well. ln, log, they have same properties. Please don't confuse, okay? Even if you have log here, you can simplify, yes. Same properties, yes. And sure, I will take one question. Look at here. I have a question with log, so we can simplify with same property with logs as well. We can take, okay, I think just give me one more question, we can go. It's up to you. Tell me which question you want.
most the hardest.
I have done the hard 70, which was both
68.
68 or 67? 68?
67.
68. Okay, I think go 68, it's fine.
Or both.
Yeah.
So x plus 1 power 10 divided by 2x plus 1 power 5, it has, okay, power and power, okay, we can go for that,
You can
68.
multiply the power with the powers, like half times 10.
Yes, actually, we have two options. Both means any one option we can use, no problem. Y is equal to we have square root and x plus 1 power 10, x plus 1 power 10 divided by 2x
Plus one to power five.
and power 5. Okay, and the objective is find y prime. Yes, please, please.
I'm telling you, it's on the class.
Yes, yes, go ahead, please. Most definitely. Please try yourself first. Good. And then we can work together. So whatever you feel easy, use that way, please. Means, I mean, of course, don't use here, direct differentiation is complicated. Apply ln both sides, please. I'm telling you, for the purpose of simplification, what you feel easy, go for that. For example, someone says, I will multiply the powers with 10, 5 is okay. Or means you can bring 1 by 2 outside, it's up to you. No problem, both works, both ways works, please.
Which is easy.
It's up to you, you can choose which is easier.
Doctor, what's the first way?
Right now, can you simplify right now? Can you simplify? No, can you simplify right now?
No, no.
Of course, no. What do you need?
Then-
Very good. So set one, apply, and then both sides. Then start simplification.
Like we can do like, as I said, all in one.
Yes, yes. I mean, if you are confident, you can use all the property in one step. It's fine. So you have taken half outside, okay. Then you have x plus 1.
I should put them,
See, when you are using the subtraction property, so this ln also come here. Means ln numerator minus ln denominator. Okay? Yeah.
I'm not sure we find the derivative, right?
Are you sure that no more property work now? Look at here. This is the argument. It has power. So
Put it also.
yes, down before and done. Okay. So so 10 by 2, 5. Good. You distribute the power. I think it's good. So 5 and x plus 1, 5 x plus 1, nice. 2. Y prime 5 by x plus 1. Yeah, very good. I think it's the best option to distribute the power. Good.
That's it.
2 by 3. 2 by 3, 2 by 3.
I multiplied 1/2 and stuff.
2 times, it should be 5 by 2,
Oh, yeah.
right? Yeah, please go ahead.
I'm going to.
Yes.
No.
So 10 times and then look at it. What can happen here? You can multiply the argument, not the product piece. 10 images, please. You cannot multiply.
Oh.
No, it's from here to here. How can
What was the part?
you can be not please. If you start there, immediately, also immediately, that's it.
Yeah, I was on start. I think
Yeah, so yes. Yeah, so it is. So 5 by x plus 1, 5 by. So yes, this is fine. Yeah, put the y value, please. Y means question, please. Okay, you made more, okay, good. Then 10. Okay, actually, if you want to take this half, so this 10 can cancel by 5 and 5. I should be getting 1.
Here it was 5 and then, yeah, then this is on this is 2. So on these, we have it like that. Here, this is that person. Yeah, it was not so it's right. It's this one. It's heading
Okay, so if you distribute half, so it becomes 5 and 5.
Yeah.
And why is the question? Okay, good. Yeah, please. Anyone has to have that?
Yeah.
Okay, this one, please. 10 and 10. Very good. 5, 5. Okay, good, because divide by this one. And 10 and 8. Actually, in numerator, it's what we numerator. Second, please, we have something in numerator. Yeah, please. Yes, very nice. Yeah, same as the finish. She's going to be fine. She should go on. It's okay. Both are fine. It's fine. 5 minutes. Okay, good. Yeah, good. Okay, very nice. At least we have the idea. Very nice. Okay, means actually, as I told you, means that you can apply. You can apply both the ways. Means here after implementing on both sides, please. In my opinion, it's better to distribute the power because this half power is on the entire function, is okay. So 10 times half, how much? 5. Then 5 times half, 5. So immediately you can basically reduce this power. So you have x plus 1 and 10 times half is 5 and divide by here 2x plus 1 and 5 times half is 5 by 2. And of course, basically, sorry, this is basically argument. Now, now you can apply the quotient property and same time you can apply the power of the argument. Means what we can do, look at here. This is 5, then ln x plus 1. X plus 1. Then minus. Because we have this quotient is then 5 by 2, then ln 2x plus 1. And basically this is your ln y value.
So number.
Sorry, wait, no,
Yeah, right now, I just simplify first. Please, please.
Is it fine if we like didn't,
Yeah, it's okay. It means you can keep this 1 by 2 outside. And then this stuff you can keep inside. It's okay, no problem. Yes, please.
I think not outside.
Yes, it's okay. She asked same question. No problem, please. No problem. Even at the end, you get same answer.
Doctor, can you do that in question 70? Like 1/3 and then you multiply? Then it has power roots.
No, actually, in the 70th question, there is no power of the function. Get it. Only
Yes, the power function become 1/3.
no, in that case, you see x power 1 by 3, x plus 1 by 3, x minus 1 by 3, xk plus 1 power 1 by 3 is too much, please. So at the end, you have the common factor at 1 by 3, which we had already. So in the answer is 1 by is outside as one factor. Okay, so no need for that here, please. So now you can apply here the both side derivative, please. So it is, you know very well, it is 1 over y and times y. And we need because this stuff, so this y, if you don't mind, this y basically, you can treat here as a product. Okay, and yeah, and now here, please, this is 5 and over x plus 1 because 5 is constant, no change. 1 over argument times the argument derivative, which is 1. Again, 5 by 2, and here it is 2x plus 1, and times argument derivative, how much? 2. So put the y value, please, the question. So when you put this question, please, here is a question, please, and then just simplify it. 5 over x plus 1, and mine I have this 2 to cancel out. So I have only 5 divided by 2x plus 1. And that's all. Those who have taken 1 by 2 here, so you have 1 by 2 here. Okay? So both ways works, please. No worries. Kindly put here the question value, please. Okay? And is y prime. So I hope you understand. Get the idea? Very good. So please practice more question on this topic. Yeah.
Can you repeat this one? I can't understand.
This one?
No, the two, when you cross the two.
Actually,
Yes.
this is my argument. So 1 over argument, which is 2x plus 1, multiply argument derivative, which is 2, which is 2.
Okay, then how do you cross it? Like,
Because I have 5 by 2 already here.
yes.
So that's why this 2 and 2.
Okay.
That's it, it's like we didn't write the one, right?
We did not write the y value. Actually, technically it is wrong because y prime has not y value here because you have the y available in x. So please put the question back. If you don't have y value, it's like then don't put is okay. But because you have y value, so you should substitute this. Yeah, please.
So, we don't have to put the value manual.
We have got to make the common denominator. Actually, you already have too much steps, so if you stop here is fine. No problem.
So,
Okay.
you write, y and the question.
Yes, we write as y as a question, exactly, please. Please write here, means y and the question. Is okay?
So in the exam, you can't write only y. Should I write?
Yeah, please put its value because it's very available. Sometimes, as he said about the implicit differentiation, there's no y value and we can't put. But here we have available, so put this. Any more questions about this topic? Okay, so we just finished differentiation part of natural log with different, type of question here. Let's go now with antiderivative, integration now. So before I start the integration phase of the questions in 7.2, I just would like to share one integration technique, please. Okay, one more rule of integration. In Calculus 1, if you just, review, you have finished integration of sine, integration of cosine, then you use integration by substitution, remember? Yeah, this part is you. Substitution is the backbone of the integration. And you will see here now in Calculus 2, whenever you go for integration, 99% we go by substitution. We put with u, yes. Because the integration are very complicated and you know very well, substitution make the question easy, okay? The other way you learn in Calculus 1 is the other way around. For example, you see the question is the derivative of which function. For example, if I ask you, what is the integration of secant square x dx?
Done.
Yeah, so what you observe, you just think secant square is the derivative of which function? So secant square is the derivative of what? Tangent. That's why antiderivative of secant square is a tangent. Understand? So this technique also you learned in Calculus 1. Then we learned some techniques with the help of identities. Means sometimes question is not integrated directly. So what we did, we use identity. Means 1 plus 10 square equal to what? Secant. Because we cannot integrate, 10 square, that's for example. So we change into what? 1 plus 10 square is secant square. So 10 square is secant square x minus 1. Means this identity we can use. 1 plus 10 square x is equal to secant square x. So please, this identity we also need, okay? And there's one more identity, please. What was that? Remember?
Cosine square plus sine square equal to 1.
It's a yes, this one also you can use the other one, please.
Plus
1 plus 1 plus cosine square x.
equals negative.
No. Positive. Yeah, so these two I then also keep in mind too, okay, we need. Anyway, means, so this stuff you have done already, basically, okay? Now, we add one more, which we use here now in 7.2, please. So, there is one more identity, sorry, one more integration, rule. It's called integrate dx over x. So whenever you have
LNS.
some question like that the denominator differential is up available. So yes, it's what? It is ln absolute value of x plus c. Means this denominator will come here like that, is here. And in the argument, we put absolute, you know very well. Why?
Because it's going to be undefined.
Because negative arguments are not defined. ln -10 or -3, you can check. It's not defined. And it has no answer with negative sign, please. That's why we always take here that the argument is always positive. Otherwise, it becomes undefined function. Okay. Same thing I can use in terms of u, please. du over u equal to what?
And that's multiplied.
Then absolute value of u plus c. Why plus c? Because this is indefinite.
Indefinite.
If we have limits, become definite, so no need for c. Yeah. Right? So now this rule we have to use now. So du by u is basically an absolute value of u, and plus c in case of indefinite, and without plus c, please, in case of definite. Okay, get this.
We're gonna take both definite ones.
Yes, of course. Yes, of course. All are now available. Sorry, yes, please. Yeah, please, right. By the way, they are same. I change the names. Here I'm using x variable, and here I'm using u variable, please. Because mostly we use, as I told you, in integration we use substitution. So mostly you get du by u. Because in almost all the integration question we use substitution u. Okay, that's fine. Yes, please. Yes, please. So here I just give the example, and then here I just give the identities which we have done already, please. 1 plus 10 squared and 1 plus 12 squared. Okay, we go now?
Yes.
Okay. Let's start, please. So here we have integration part. So look at here, this is the question now, evaluating integrals, please. Okay. So now, first is very easy. Let's go with the 40th question, please. This one, please. So we have -1 to 0 as limits, please. 40th question, please. We are going back. So question 14. So integrate -1 to 0. -1 to 0. 3dx over 3x minus 2. 3dx over 3x minus 2. Okay. So now we have integrated, and I told you already, please, we use substitution, please. Always, exactly. Very few cases are there where we not need integration. In case it's very straightforward question, very easy. The rest we have to use substitution, please. Please tell me, what take I take as u?
3x minus.
We know very well. The complicated part we take as u.
Mm.
So which part is complicated?
3x.
3x minus 2. So please that 3x minus 2 is equal to u. Now differentiate. Take differential both sides.
3dx. 3
Yes, 3x differential is 3 times dx. Who is constant? Derivative 0. What is u differential?
du.
D. After taking differential, just stop here. Go back to the question and try to match. In my calculation, I got 3 dx. Do you have 3 dx in your question? Oh, yes. Someone gets it. This is 3 dx. I also have 3 dx.
So we're like,
Is value how much?
du.
Du. So 3dx will be changed into du, divide by u. What is 3x minus 2? Du, okay. Don't put these limits here because these are x values. Now no more x. What is that? It is u now. So please don't put the value, please. If you want to put here values, so put the u values and get from here. Put here x 1 by 1 and get substitute. Yeah, so no need to put the values, please. Just keep it blank. Go ahead. What I told you. What is du by u? Oh yes, it is 100% ln absolute value of u and plus c, right?
Yes.
Yes.
Because it's
Yeah, no.
It's indefinite.
Not that's.
Plus c or no?
No.
Don't know. Please don't write plus c. Why? Because this is we have limit. We have lower limit. We have upper limit.
But we can continue solving it without the last one, right? Without the
Without any.
this du over u. We can continue solving it without the whole you said before.
Which rule?
Without the last step, continue integration.
Without using ln.
Without using ln, how we can get the answer?
Use program.
Huh?
Use power negative 1 we can't do.
So look at here, please. When we substitute, we got this one, and this is du by u. It is basically ln u. We just finished. Du by u integrates ln u, right, please? Now, what is u value, please? What is u? Check here. How much? 3x minus 2. So put back now u here, please. So it is ln, and it is absolute value 3x minus 2. And please, it has limit from where to where?
From negative 1 to 3.
Negative 1 to 0.
How do you know it's difficult?
Because look at the question, please. In the question, do you have limits?
Yeah.
So it's definite. So if there is no limit, it is indefinite. So in your answer, you have plus c.
There's no sound.
Yeah, means it's called limits, lower limit, upper limit. If they are if not provided to you, it's indefinite. So we have here, so it's definite. So the answer is a number. The answer of definite integral always a number, a constant. And you can see now. So please.
I remember in Calculus 1 we used to sometimes like substitute in the 3x minus 2.
Yeah. To get values. Yes.
We should do it or not?
No, I did not do here.
We can do it
No need for that.
if we want.
Oh, if you want, it's up to you. Waste your time, it's fine. So you keep blank. At the end, put the u value in x.
Because we're back to the
Yeah, exactly.
Not substitute.
Put back and then use the values which are given here.
Yes, one.
Because sometimes here substitution is very complicated. Means sometimes it is cosine function or cosecant function. To find u values takes time. So that's why no need. Yes, please. Some question was here. Yes. Any question, please? Okay. So now, as we get the answer, please upper limit in the answer minus lower limit in the answer. So we have now, this is ln absolute value 3 times, how much upper limit? 0. So 3 times 0 is 0. You have now minus 2 absolute value. Am I right, please? So we have minus 2 absolute value. Minus, because the rule is that upper limit minus lower limit. Okay, so ln, again, please, 3 times minus 1 is minus 3. Minus 3 minus 2 is minus 1. Good, okay. See, this is the way, this is the reason why you put absolute value. If there is no absolute value, ln minus 2, how much check?
Undefined.
Is mass error, undefined. That's why you can't get any answer. So whenever you put ln in the argument, put the absolute value. Okay. So you have now ln 2 and minus ln 5 because absolute values makes minus 5 minus 2 positive. Correct or not, please? Okay. The answer is ln 2 over 5. Yes or no?
Because
Probability.
property.
Quotient.
So if you have subtraction between the ln's, you can write as a quotient. If you have product between them, so we write as a, sorry, if you have addition, so you can write as a product.
If you leave it, is it okay? Is it correct?
This is simplified. Okay? Yes, please.
Like in the previous questions, we used to do the quotient as in the,
It goes vice versa.
vice versa. Like in both ways, it is simplification.
Yes. Of course. Yes, please. Any more question?
Actually, it's come
Can you solve it without substitution?
It's okay. Means some questions you can answer without solution. If you are confident my answer is not wrong, yeah. Okay. The solution just make the question easy. So, but if you are confident, I can answer without that. Okay.
Doesn't.
Done. If without substitution you are getting your answer correct, is fine. Yes, please.
the last two answers are right.
We need this one, please. Because it can be right like that, please. It's simplified form. Okay? Let's go for more questions. Okay, so let's take 48 questions. 48, 2 to 6 in the limit and divide by 2x times lx squared. So 48 question we can go. Okay, so okay, 47 to 48.
So.
Uh, 47 you can try because it has answer, you can check answer. Let me answer the 48 please. So we have 2 to 16 and this one dx,
Over 2x,
2x.
square root and x.
Okay, please try yourself, please, come on. Please, go ahead.
Because on this question, we'll take u as the next one.
And then when it
Exactly. Whenever you take the, substitution, we always take without power, yes. So you take u as ln(x), correct? So do the question and put the limits, so share your answer, please. Put the answer, the last simplified value. Yes, get the answer?
And it's a
Usually, you don't have x and u together.
yes.
So either you have completely x or you have completely u. The combination of. So get the basically x as the value of u. Answer?
Use E.
Oh, no, use it for choice.
so it's we substitute we get the u and then we need the derivatives.
Yeah, exactly.
Okay, I'm not sure about my
But actually, see, why you are taking ln x square root as you know, please.
I'll put it 1/2.
No, no. Whenever we take substitution, we take substitution without power. Take only ln x as u.
Okay, but you not have to, you put through the.
Like you put the doctor.
Plan two.
Yeah, we can.
From the other side.
We can. Yes, the other side, yes, the other side. Slip my work, please. Slip my work, please. Yes. Okay. Okay, okay, that's great, that's great.
Oh, it's you.
Okay, it's not absolutely, please be careful. No. Again, go back and check the formula, please. Yes, please. Anybody has got the answer now?
Wilson.
Yes, we'll answer.
I'll answer for.
Ln. But you have limits. This is limits. Yeah, this is two limits. Because the answer is a number. Yes, please. You got the answer, please? What answer? So 2 times 7 is 2 and you see, look at here. If you have this not okay. This it is it is a direction right as a motion, right? Yes, you're done. Do you or you? I sure you have only you or you power half. So answer is this. Eliminate by 2. This we can use. Eliminate by 2. We can simplify more. Okay.
Square is 8.
Huh?
Square is 8.
No. Means how can you write 8? 8 should be as 2 power 3. Okay, please up limit minus lower limit, please. I think yes. So please apply the limits, please first. Then check the answer, please. Okay, so. Right, so as I told you, please, in substitution, when I use substitute, please substitute the difficult portion, but without power, please. So if you compare 2x and this one,
Don't put it.
of course, means lnx is a more complicated part. So let lnx is equal to u. Next, we need differential. So this is 1 over argument times the differential of the argument, which is dx, and u is du. That's the point? Just stop here and go back to the question and you check please, do you have in your question dx by x? And if you observe, oh yes, we have dx by x. So this 2 is constant, you can keep outside.
But if you put it in the question, is it correct?
In the question,
And like here, you multiply 2 by 2.
oh yes, means in the case you will multiply both sides, yeah, it's okay, no problem. So now I have 2 times, sorry. This 2 is 1 by 2 outside. I have integrate. Now dx by x is how much? Du. Divide by. And x is how much? Du. And be careful, it has square root. Yes, no, I just substituted the values here. So after substitution, I got this one. Are you getting same thing?
Yes.
All of you?
Can you apply ln with the square root?
No, not possible, please. Here you cannot apply ln, please. So in the rule, if you look at it, the formula is that integrate du over u. How much the power of u in the denominator?
1.
Is 1. If it is 1 power, then you say ln absolute value of u.
But here.
Right now,
It's half.
power how much? Half. You cannot apply at all, please.
Square root.
So basically, here we use which rule, please?
It's perfect. Love.
We use the power rule. Power rule of integration means you have to take it up. Take u power half up, it becomes negative half. Do you understand?
Yes.
This one, take it up, please.
Then.
So in the down is half. Take it up becomes negative half. Now you have to use the power of integration, which is n plus 1 divided by n plus 1.
So,
Minus half plus 1 divided by minus half plus 1. So
so two,
this is 1 over 2. So this is u power minus half plus 1.
It's fine.
Also divide by minus half plus 1. Don't write plus c because we have limits.
so we come at that one, two, one.
So now, just simplify please one more time, is 1 by 2. How much minus half plus 1? Half. Positive half? Okay, so you have u power positive half. Down also you have positive half.
So, 1, 2.
And it will flip.
Yeah.
Okay, good. Means if you understand here, very nice. So I can put this 1 by 2 in the denominator like that, 2 times. Is okay? Because divide is half, it flip. If you 2 go up
Two cancel two.
and 2 cancel 2, very nice. 2 cancel 2. And now do one thing, substitute u value back. What is u? U is ln x. You are right, please. So this u is now ln x. And it has half power. What does it mean by half power? Square root. Half power means square root.
But why you think that?
Sorry.
Why you think that next?
Because my u is ln x. My u is ln x. Okay. Now please don't forget we have limits from where to where?
16.
2 to 16. Okay. Now substitute upper limit minus lower limit. So ln 16 in the square root minus ln 2 in the square root. Yes, please. Yes.
That's how I just for the argument, not the whole function.
No, u has power. U.
Also, it's the whole function.
Yeah, u has power. So what is u? U is ln x. So ln x has power. Please, my friend.
Why you think that was the power of two?
No, it is this separate, please. It is limits from 2 to 16. Okay, so I compute upper limit minus lower limit. Please, we can simplify more.
Yes, 16 over 2.
Okay, now look at it, please. Look at it. 16, I will write 2 power 4. Yes or no?
Yes.
Okay. Minus ln 2 minus scale. Okay. 16 I can write 2 power 4 and the 2 is the argument. Argument has power 4. So by property, what we can do?
You write the 4.
So it is 4 and then 2 in the square root. Yes or no?
Yeah.
What is 4 square root? 2. So
Doctor, if you don't do this, it's correct.
use the marks. If you do not simplify, use marks, please, because the answer is this one. 2 times ln 2 minus ln 2 square root.
Yeah.
And now ln 2, ln is a common factor. So ln 2 square is a common factor. I have 2 minus 1. So finally, the answer is ln 2 square root. This is a constant value. Is a number. ln 2 is a constant value.
You put it on the
This one? I don't know.
We can put it in the calculator, root length 16 minus length 2. We will get the answer. Why we should have, why we should,
So what answer you are getting? Same answer getting?
use the calculator with 5 words, it will give the same answer.
Try please.
Not give you a line.
Yes, please.
Can you go up?
Yes, please.
The 2 square root is ln 2 minus square root ln. Does not understand how we gain 2 minus 1.
This one?
Yes.
From here? Ah, okay. Between these two, what is common factor?
ln 2.
So if you have taken common factor, so this is gone, here is 2,
Yes, and here is
1. That's it. 2 minus 1, how much? 1. Yes, please. Any more question? So have you got the answer from the calculator?
Can you get it on the calculator?
I'm not sure. I don't know about that. I never use a calculator, please. You can check it.
What should we put in the calculator exactly?
I don't know. I don't know. He said I put something here so I get the answers. I'm asking, are you getting or no? Yes, I'm getting the answer in the calculator. Decimal, put it out. It means you have to
Yeah, you're
perform.
getting it this.
So no, it means not working. Doesn't work.
The same value.
Huh?
It's the same value.
Now we need the complete number, no decimal place. And you see in all your answers, if you check the odd number question, the back, all are complete, no decimal answer, not at all. Because there is no concept of using calculator in calculus 2.
Yes, because like we can know the value from root length 16 minus root length, same answer.
You are getting the ln to square root, square root.
No, I got the answer. The answer of length.
No, asking, I'm getting ln to square root in the calculator.
No, the value of the length.
No,
Ah.
please. This is a problem. That's why I said you have to perform these calculations. Okay, now understand the question. Let's try it, please. One more question, please. Okay, before we go, please, try question number 53.
54?
53. 53, yeah. Come on, 53 question, please. Pi by 2 to pi is a limit, 2 times cotangent, the angle pi by 3 d theta. Please. Okay. 53, please. Yes, please. How you start the question?
Do you think it's as cosine over sine since it's cosine?
Yes. Yes, good. So you know how understand how to start the question? Cotangent is basically is cosine by sine. So first of all, you have to write cotangent as cosine theta by 3 divided by sine theta by 3. Exactly. So you have to first of all please write this one. Who is constant you can keep outside. This is cosine theta by 3 divided by sine theta by 3, okay, and then d theta. This step 1, change cotangent to cosine by sine. Next step,
Take sine over three as
sine theta by 3 as
U.
u, yes.
Why
Why
sign?
did we choose it?
Please select cosine and check what I get.
Because the derivative of sine is cosine, so it will be answer.
And no, actually, it's the
Negative.
derivative of cosine is also sine, but what happened? You get u up and u down. You get u over du, which is doesn't make sense if you use cosine as u, please. Okay, means if you take cosine as u, you get this one. Integrate u over du, which is not. No.
Let's get a separate.
du over u.
Yes. So take sine as u. So when you go for this substitution, please find theta by 3 as u. Quickly 3, so you have sine theta by 3 as u. So the differential is sine theta by 3 times 1 by 3 d theta is equal to du. Right, please? So if you go back to the question, please check. You have, so you can see we don't have 1 by 3 in our calculus. We only have cosine theta by 3 d theta. Okay?
Multiply 3 by.
Yes, so this 3 you can cancel out by times 3 here and times 3 here. So this is cancelled out. Now I have cosine theta by 3 d theta is equal to 3 times d. So my question was here, this one. 2 was outside. I have cosine theta by 3 d theta over sine theta by 3. Okay, and here, sorry. And I have limits now. Where to get this?
5 from 5 over 2 to 5.
5 over 2 to
5.
5. Yes, okay. So I make a substitution. After substitution, you can see what is cosine theta by 3 d theta value? 3 du. Very nice. Good. So this value is basically becomes 2 times integrate 3 d value divide by sine theta by 3 is how much? U. This 3 and 2 can combine. So 3 times 2 how much? 6. What is du by u? Ln u absolute value of u. Don't write plus c. We have limits. Put back u value is 6. Ln absolute value. U how much? Check. 9. Theta by 3. And it has limits from pi by 2 to pi, pi by 2 to pi. So now please substitute upper limit in the answer and minus lower limit in the answer. So hopefully you get the answer, please. So 6 times and then absolute value sine. Okay, upper limit how much? 5. It becomes 5 over 3. Yes or no?
Yes.
Minus 6 times ln absolute value sine. Now lower limit how much? 5 by 2. You also have 3 down. So 3 times 2. Yes. Kindly give me the answer of sine 5 by 3, please. 3.
Square root 3.
Okay. So this is 6 times ln, and you told me it is square root 3 over 2. Fine. Minus 6 times ln. Give me sine 5 by 6, please. Half. Okay. 1 by 2. Absolute value. Okay. Now look at it. Root 3 is constant, right? 2 is constant, right? They are positive. Half is positive, yes or no? So no need for the absolute values, please. You can remove the absolute values. No problem, please, because they are already positive.
If they were negative, we're gonna remove the absolute.
Of course, no, not absolute value. Means the out become positive. Okay, now 6 times, can I write this one like ln root 3 minus ln 2? Yes or no?
Yes.
Okay, minus 6 times I write ln1 minus ln2. Yes or no?
Yes.
Because the argument has fraction. Fraction change to subtraction. Fraction change to subtraction. What is ln1? 0. Exactly. So now we have here 6 times ln square root of 3 minus 6 times ln 2. This is 0, negative, negative, positive, 6 times ln 2. Because ln 1 is 0. All of you understand? It is 0. Finish. Negative, negative, positive. Clear? What else we can do is this cancel. Okay. 6 times divide by 2 ln 3.
Why?
I don't know.
Because they were over 2.
Can you check how I write this?
Doctor, the square root made it 1 over 2.
Yes, basically, because this is the argument and it has powers r. Yes or no?
6.
So with the property of the natural log function, r will come down, becomes 6/2 and ln 3. This is cancelled out. So you have 3 ln 3. This is simplified answer. Yes, the answer? Very good.
Can you
I hope you get the, the concept that how we are going to calculate these values. So we need simplified form, please. Be careful. We need simplified form. You have marks for that. You have marks for that, please.
How much?
Huh?
Don't know how much.
Sometimes 0.5, 0.75, like that.
That's okay. From one, maybe from 3, from
Oh, it depends. If it's 2 marks, then 0.5, 0.75. 3 marks for 1 mark simplification. So please go for the last answer, please.
so they don't want the value, want the simplified formula.
Yes, exactly. Don't need 1.0003 point or no, we need the answer like that. Understand, please? Means we have something else more in this part because it's your choice now. It's your turn now. You have to practice, please. These questions means practice, and then let me know if some question you do not understand. Yeah, we can go break now. So after break, we can start 7.3, please. Because now go back home, take the question from this topic. Please, if you have some, difficulty in some questions, bring that question next class. So I will explain to you, right? Let's wait. I think it is first, then you can do.
The,
Yes, please.
the book is not working. Yes, but it's not,